Hello everyone, welcome to Agentic RAG from Scratch series. In this series, we'll build a production grade Agentic RAG system from scratch. This is episode 4. In this video, we are stepping things up. We are going to understand what tools really are and more importantly, how they unlock your application's ability to take real actions. Then we'll build our very first tool, one that fetches Rob's customer profile. And then comes the exciting part, agents. We'll break down what agents are and transform our simple chat model into a fully capable agent using LangGraph. So once again, welcome to Building SaaS. Tools are what turn our application from something that just talks into something that can actually do things. They allow our agents to fetch real-time data, execute logic, query database, and interact with outside world. Under the hood, tools are just callable functions with clearly defined inputs and outputs that we register with our model. So let's understand how tool calling actually works. LangChain gives us a simple way to define tools using a decorator @tool. When we decorate a function, we are essentially telling the model this is something that you can use when needed. We also provide a description either explicitly or through docstring, so the model can understand what this tool does. Let's take our first step. We'll convert our existing getUserProfile function call into a tool. We'll add a docstring to describe it and define a return type so everything says structured. Next, we bind this tool to our chat model. This gives us a new model instance, one that is now tool aware. Now let's see it in action. We pass a simple user query, what is my name? At this point, something interesting happens. A model doesn't directly answer the question. Instead, it responds with a tool call. It's basically saying, I don't have this information yet, but I know exactly which tool can get it. But there is something important. The model does not execute the tool. It only suggests the tool call. So now it's our job as a developer to handle that. We loop over the response, check if there are any tool calls, identify which tool needs to be executed, and then actually invoke the function. Once we execute the tool, we take the results and append it back into our message list. This step is critical because now we are feeding the model new information, real data fetched from our system. Finally, we call the model again with the updated context, and this time it has everything it needs. So it responds with a clean human readable answer. Your name is Rob. And this right here is the foundation of tool calling. We have just built a system where the model can understand what it doesn't know, decides how to get the information, uses tools to fetch it, and respond intelligently. Structured output allows agents to return data in a specific predictable format. Instead of parsing natural language responses, you get a structured data in form of JSON objects, pedantic models, or data classes that your application can use directly. Let's start by creating a pedantic class with name property. The same way we bind tools to a model, we can also provide model with structured output. Then let's pass the pedantic class that we have created and then invoke the model with user given input. As you can see, now we are getting the name as a pedantic object. Right now, we are manually handling everything. We check if the model wants to call a tool, we execute it, we append the result, and then we call the model again. This works. But imagine scaling this to multiple tools, multiple steps, and real-world workflows. This quickly becomes messy. So instead of manually managing this loop, we can define it as a structured flow. This is where LangGraph comes in. LangGraph is a low-level agent orchestration framework that focuses on durable execution, streaming, memory management, human in the loop. LangGraph provides two kinds of APIs to create agent orchestration, Graph API and Functional API. In this tutorial, we'll only look at Graph API. At its core, LangGraph model agents workflows as graph. You define behavior of your agent using three key components: state, nodes, edges. Let's take a look at each one of them. State, a shared data structure that represents the current snapshot of your application. It can be any data type but typically defined as a shared state schema. Nodes, Functions that encode your logic of your agent. They receive the current state as an input, perform some computations, and return an updated state. Edges. Functions that determine which nodes to be executed next based on the current state. By composing nodes and edges, you can create complex looping workflows that evolve the state over time. Now, let's convert the existing application into LangGraph. Let's start with imports. We'll import state graph, end, and start from LangGraph's module. In LangGraph, everything revolves around state. This is the data that flows between nodes. Here, our entire application state is just a list of messages which represents the conversation. Next, we already have a getUsers profile as tool. This function reads local JSON file and returns a customer data including names, card details, and maintenance history. Once decorated, this function becomes something the model can choose to use. Now we initialize our model and bind the tool. This creates a model that is aware of the tools we provided. Now we define our first node, the model node. This node sends the current messages to the model. The model processes the input and returns a response. This response could be a normal answer or a tool call. Next, we define the tool execution node. We look at the last message, which should be from the model. If the model requested a tool, we execute it. For each tool call, we run a function. And then we return the result as a tool message. The tool call ID is critical. It links the tool result back to the exact tool call made by the model. Now we define how the flow should continue. If the model requested a tool, we go to the tool node. Otherwise, we end the process. Then we start by building our graph. We first initialize a state graph, a graph whose nodes communicate by reading and writing the shared state. Then we add our both nodes to the graph. Then we'll start connecting all the nodes that we have added. Let's start by adding a start node that points to LLM node. Then we'll add a conditional edge that will check if the tool call is needed or not. Then we add another edge connecting tool node to LLM node if the tool node is executed. Then we compile the graph. This step validates the graph and returns a compiled state graph instance. We can draw the graph that we have created so that we can better understand the flow. Then we invoke the compiled graph with the user message. Then we take the results and loop over it and print the output. Now let's execute the program. We have invoked the graph with a user message, "What's my name?" Model understands the query, decides it needs to call a tool to get the user info, makes the tool call and sends the response back. This will also generate a graph image. When we explore the graph image, it will tell you exactly the flow of the graph. So till now, we have seen what are tools, how to make tool call, understand basic workings of LangGraph, and converted our application into a LangGraph agent. That's it for this episode. In the next episode, we'll dive deep into LangGraph library and understand concepts like persistence, durable executions, interrupts, memory, subgraphs, and many other concepts of LangGraph. Do subscribe to Building SaaS channel and turn on the notifications so that you don't miss the next video. Thanks for watching. I'll see you in the next one.